then we'll go into the specific case study, okay? All right. Geo-match market testing, assuming you have objectives, assume that you've already gone through this kit, and then we have objectives defined. So, and now we're going through what the process might be, okay? So here is the very first thing you do in any testing exercise is objectives, okay? So you have to figure out what is the valuable question that the brand is actually grappling with. Is it trying to understand the efficacy of the current investment? Are they trying to scale the investment and they're trying to understand the marginal return they might get for the additional investment? Or is it channel A? Is it channel B? And there may be various ways they may ask the question. So trying to figure out and dial in the objectives is the very first step. The second step is data prep. Now that you know that what you're looking to do is test Facebook or TikTok or TV and whatnot, now you have to go grab all the relevant data and prep those sheets we talked about. I gave you access to a bunch of sheets, the sensitivity analysis, the geo templates and whatnot. If you don't have access, I'm happy to give you access as well. It's part of the class. So you have to prepare those sheets. And these are all the things that you would do, right? You will get these data sets, daily conversions by market, percentage contribution estimate. Well, that's what the sensitivity analysis is very useful for. How do you know what's the contribution of Facebook before running a test? Well, you have to somewhat estimate it. How do you somewhat estimate it? Well, you take the sensitivity analysis approach we discussed in class. Allows you to get an estimate, so you can kind of say, well, if is the Facebook contribution likely to be 25% or 2%? If it's 25%, it's very testable. It's 2%, it's kind of not testable, right? So kind of allows you to figure out, in terms of sort of ballpark, how these channels are going to get shaped and what kind of tests might even be relevant to run for them. Okay, population by market. There is this is a public data set that a lot of governments put it out. In the US, we have a census data set that I go grab. I actually make this available in class for the US markets. There is actually a data set. I make it available, so you can just grab it from the M squared and from the M squared workshop section. And the market mapping data set. What does that mean? Is that you have to be able to map zip codes to DMAs, to states, to, of course, the overall country, right? You have to break it up. You need a mapping data set for it. So again, I have the data set available for you as part of class. So anytime you're doing a zip level test or a DMA level test or a state level test, how do they map it? How do you take data from Shopify that rolls up at the zip code level and then map it to zip codes, map it to DMAs? How do you do that? You can use a VLOOKUP to do that, but you need a fundamental foundational data set for it. So that's the data set. Again, these are the foundational data sets you need. And then I have two templates. A cell design template and a feasibility analysis template for geo designs, again, available as part of class. You prepare all of this stuff as part of class, as part of your analysis. And that's the starting point for geo testing, okay? Then next step is test design, okay? First is market selection. We went through all the statistics, but fundamentally what we're trying to do is identify matched markets, okay? Is California matched to Rhode Island? Is Texas matched to Kentucky? Is New York matched to Maine, right? We're trying to figure out which markets are good sibling markets so we can use the small markets as a test market and understand or extrapolate what might happen in the big markets. That's the basic idea, okay? So first step is to identify markets. Second step is to do what's called feasibility analysis. Now, what is feasibility analysis is you have to figure out, is this test feasible? Okay, there's a basic concept in all geo tests called minimum detectable lift. We call it MDL. In the statistics literature, is discussed as MDE, minimum detectable effect. Okay, sometimes people use those interchangeably. Okay, so minimum detectable lift. So which means that if your markets are changing every day, like if you go pull Shopify data, your backend CRM data for New York, okay. And if you just observe it on a weekly basis, there'll be natural variation. It won't be just a flat line. It'll be like, it'll go up and down a little bit, right? Now, what you're trying to do is you're trying to, let's say, for example, cut Facebook spend. You want to make sure that the markets are going to drop well beyond the natural variation. Okay. So let's say the markets are varying by 0.5%, 1%, 2%. You want to drop those markets by like 8%, 7%, 10%. So that you can actually just visibly catch it and know that whatever treatment you imposed on those test markets actually had an impact or an effect that you can actually measure, okay? That is called MDL, minimum detectable lift. Okay. And there are various ways to estimate it, but there's a common sense number. The common sense number is 5%. Sometimes I've used 3%, but I've come around after many years to say that you have to be able to move markets by 5%. If you're not able to move it by 5%, it may be pretty hard to read in a geotest. Not impossible, still possible. It may become harder and harder and harder as you go below the 5% number. Okay. So when you are doing feasibility analysis, the rule of thumb is to estimate if the changes you're going to make to those markets is going to have an impact on those markets greater than 5%. So if you're trying to cut markets, cut spend, go ahead, Rashmi.
I have a question on that. Before conducting the test, how would we know that the lift would be greater than 5%?
Beautiful question. Beautiful question. This is a very, very important question, what Rashmi is asking. How do you know it's going to be 5%? You haven't tested yet. That's where sensitivity analysis and estimating what the course impact might be becomes very important. Okay. Now, you have to have some sense of what it might be doing for the business for you to test it. Okay. And how do you get some sense for it? Is you go through this process called sensitivity analysis that we discussed in class. And why is that the first step we discussed in class? For exactly this case. So that you can go get a core sense of what it could be delivering for your business. So then when you come here, you can use that estimate and feasibility analysis to say, well, this is testable. Yeah, I'm spending, like a good example for a very feasible test is the test we're going to discuss right now, which is a true classic gene Facebook test. Okay. They were spending about something like 65% of the total budget on Facebook. And when we did the sensitivity analysis, we thought that we estimated that Facebook could have an impact as much as 50% of the total new customer acquisition could be coming through Facebook, or as little as 30%, 26%. So there was a big band, it was well past the 5%. So we knew it was very testable. Okay. Now, I've been in many situations where you go through the analysis, you find out that, well, it could only be 1%. If it's really 1% contribution, it's not a candidate for a geotest. It's not possible to geotest it. Okay, so you have to look at other approaches for measuring it. But geotest becomes an approach that becomes infeasible. Okay, now why this is important is that you don't want to go through the entire rigmarole of like designing the test, putting it in market, getting the data, and then figuring out there is no lift. But when you get there, you don't know if there is no lift, or you ended up running an unfeasible test. Right? You don't want to be in that situation. So that's the reason why you want to do the feasibility analysis as part of the test design. So you can identify if the test is even feasible to actually conduct. Okay. So that's number 2. Number 3 is decision matrix. Okay. Now, I don't know if we talked about this in the June cohort. About half of the tests I've designed in my life, I've designed hundreds of tests in my life. About half of them I don't flight. Because when you go through the process, identify feasibility, and figure out what decisions you would make, depending on how the test might land. As an example, let's say, for example, you take this the example of Facebook, let's say. We go through the feasibility analysis and we say, okay, what is a best case lift we can observe? Well, the best case lift is 65%. What's the worst case lift you would and the worst case lift is, let's say, 25%. Okay, what is the CPA or the ROAS when it's 25% lift as opposed to 65% lift? And you find out that both those ROAS numbers are very, very positive. Maybe I'm just going to make this up. The ROAS numbers are, 4.5. Okay, it's very, very positive, even in the worst case. The decision to scale Facebook, because maybe your target ROAS is 2. It's well past the 2 ROAS, and it's way more profitable than what you really want it to be. So the decision to scale the program is obvious. You may not even need a test for it. Right. So you may say, well, it's not as valuable for me right now because I know what I'm going to do with it. Right. It's not as valuable. Now take an opposite use case. Let's say there's a use case for, let's say, a podcast. Right. And it's not quite sure. It seems funky. It seems like a really good channel for you. Strategically, it feels like a fit, but the data just doesn't bear that it could work. So you kind of do the feasibility analysis and find out that the ROAS is like, 0.1. Best case, and worst case is 0.05, and you were looking for a ROAS of 2. Well, it doesn't matter. You don't have to run the test to identify that it's actually so poor. Even the best case lift is not going to is not going to change your decision, right? So therefore, what the best practice for any test that you design is to go through decision matrix, and we'll go through that, and we'll talk about, so identify some corner cases for your test. What is the best case lift you're really expecting? What is the worst case lift that you would be really disappointed with? And then what is the average case here? And what decisions you would make on all those three cases, in whether you would scale or hold or cut, and make those decisions on paper. And that makes a huge difference when you actually run the test, because now all the emotion behind the decisions actually comes out on paper ahead of time. So you don't end up like having to deal with all the emotions of different people. And now you're just walking through the logic of making a decision. Yeah. Go ahead, Vishnu.